Optimization of Drone Frame Design Project Update by Clayton Harp. The current situation is as follows. Currently debating on constraint for a structure when running analysis, also developing simple 2D shells to run for preliminary results. This will tell me whether or not the square starting block is not refined enough, and if maybe I should go with a more conventional model. These are my current assumptions and parameters. I'm using the 1/2 MV squared over D, where D is 1 millimeter of displacement upon rest. This is typical upon crashing quads. I'm using 40 miles per hour. The total mass of the quadcopter is 413 grams. I'm using a general zero ply composite, which gives me a G of 70,000, a nu of 0.1. The model is built in the same orientation as the tutorial in the ZX plane, and the mesh size is 0.5. This is the current 2D geometry, which could also be 3D depending on thickness. It's a 200 millimeter square plate with holes that represent the motor locations and battery and other components. That slot is also used for battery as well. However, that's just a placeholder. On the right, though, however, are the conventional X-frame quadcopters that could be a better starting block than just having a square plate. I would just make a much rougher version of the ones on the right without any holes except for the motor and battery components. This is the current force model. The red and orange arrows are force components, where the black are constraint components with their DOFs restrained. Each hole was to be RBE and to combine the nodes together as one unit. These next three slides show preliminary results, where one is the single hole loading with 2 constraints, the next is a single top node loading with 2 constraints, and the next is 4 RBE holes loaded with 2 constraints. These are my current assumptions of what I think is going wrong. I'm treating this as a cantilever beam with non-reduced areas. If I want it to look like a quadcopter, then I probably should start it with a reasonable reduced area. My constraint force diagram might not be completely correct. Maybe I shouldn't have point constraints, maybe I should have surface constraints, or maybe I should have reactionary forces. And then the other assumption is possibly I should reverse and instead have constraints on the holes and then load it around the sides. For my path forward, I need to finalize the force constraint structure. Angles will come naturally afterwards. I need to get help with the RBE structure to reduce errors, and then to make the analysis faster, I need to see if the optimization can be done with 2D P-shell type simulations.